Okay, so just to finish up here, so we were looking for mu of the ground, and we know that friction on the ground is equal to mu, the normal of the ground. So the mu of the ground will be equal to friction on the ground divided by the normal of the ground. So the friction on the ground was, so mu ground, so friction on the ground was our Fn that we found here, right? Because, oh, there it is, that's what I was looking for. Friction of the ground is equal to Fn. So it is 239.6, what was it? 35 newtons. And the normal of the ground will be the mass of the ladder, 16 kilograms, times 9.81 meters per second squared, plus the mass of the person, 80 kilograms, times 9.81 meters per second squared, minus the friction of the house, which we just found down here, 47.927. 47.927 newtons. Okay, so all of this gets divided, and then you get your mu of the ground. And when you do this, I think on the bottom you end up getting 893.833 or something like that. And then this gives you 0.268099 for your mu. Okay, so it's more complicated than the others because of this extra force, and in reality I wouldn't expect 12 twos to do it. I would expect 12 ones to do it. But on that being said, on the more torque question sheet, number 7 has a friction at the top of the ladder. So if you want to give it a shot, do. The answer's there. What I'd like you to work on for sure, whether you do that one or not, is another one, find the mass, okay? And so the givens are going to be the mass of the ladder is 10 kilograms, the length of the ladder is 10 meters, and it's uniform. The coefficient of friction at the bottom of the ladder is 0.2. The person makes it 1/3 of the way up. So the R of the person is going to be 1/3 of 10 meters. Who put kilograms up there? Man. Meters. Oh, mass of the person, it is, mass of the ladder, it is kilograms. There's the 10 meters. It's because they're both 10. All right. And the theta, the angle at the base of the ladder, is 60 degrees. Okay, so ladder, so this angle here is 60 degrees, and there is no friction at the top. Okay, no friction up here. Find the mass of the person. And when you do it, see if you can get, I believe it's 117.45 kilograms. Okay, so see if in the end you can get 117.45 kilograms. So that would be one of your homework questions after we would do this lesson. The other two would be on page 529 in your textbook, numbers 27 and 28. And really that would be the end of the torque unit. If we were in school, I would be saying, what day would you like the test? Thursday, Friday, or Monday, and of course you would pick Monday. And then I would be giving out an assignment that would look like this. Now, I will give this assignment out once I am able to send you work, but since that hasn't happened yet, let me see if I can, steady it and hold it still for a moment or two, so that maybe, I'm trying to focus it too. It's hard to do, I only have 2 hands. Okay, so maybe if you're totally bored, you could start some of these, you could try some of these, but when would you hand it in? That would depend on when we are back in school and when we are allowed to send out work. But I wouldn't want you to be bored in the meantime if you're watching this or when you're watching.